Ruben Carrizales, and Alberta Zassi. Our session will be starting soon. This session will be recorded so that you may come back to it later if you need, and so others who may have missed out on today's events will be able to come back and watch it. So let me go ahead and get that recording started for us. Alrighty. So it's already started recording. Awesome. And let me pull up that PowerPoint for Ms. Chuka. Let me go right here. There we go. Thank you. So now at this time, we ask that you please mute your mic for the best sound experience. Otherwise, feedback could interfere with the information that we're sharing with you today. So without further ado, here is Ms. Chuka.
Hello, everyone. Today we're going to cover exponential and logarithmic properties. And this is going to help with sections 3.1 through 3.3. So let's get started here. If at any time you have any questions, please let us know. Okay, so in chapter 3, you're going to be looking at solving equations that look like this. And so one of the first things that we can do is to change this so that it looks like an exponential function. And so let me just refresh what that means. Let's say you have a log of base b of x is equal to y. Then we can rewrite this as an exponential function by taking the base, which is the b here. And the log is always going to be equal to the exponent. So this log right here is equal to y. So that means that y is going to be the exponent. And then our last variable would be what the exponential part is equal to. Okay, so here it says to solve for x. So one of the first things we can do is we notice here that this is a log. We can try to use our calculator, which we'll talk about calculators in a little bit. But for now, let's go ahead and change that to an exponential function. So my base is 5. So here's my base. And then the log is equal to x. So that's going to be your exponent. And then that's equal to 25. Okay. So what we can use next is something called the one-to-one property, which means that if you can write both of these bases to have the same number, then the one-to-one property is going to tell us that we can set the the exponents equal to each other. So 125 can be written as 5 cubed. And so by the one-to-one property, we can say that x is equal to 3. Okay. Let's do a few more examples here. So let's look at this one. So we change it to exponential function. Then our base is going to be 2. So we can write our base is going to be a 2. This whole log is equal to x. So x is going to be our exponent. And then 25. When this problem, there is no way for us to rewrite 25 so that it has a base of 2. So for example, 2 squared is 4, 2 cubed would be 8, 2 to the 4 is 16, 2 to the 5th is 32, so we can't write 25 in that way. So a calculator would be handy. So there's a lot of different types of calculator. The only difference though is that the calculators have to have, for these TI 83 and 84s, the log is a base 10. So we would not be able to do that problem with this calculator. Now this Casio calculator lets you enter the base. So if you notice here, you have a 5 and then you put the number and it gives you the answer. Now I'm not saying you should go buy this Casio calculator. Even if you have the TI, you'll still be able to work these problems out. But we need a method, and this method is called the change of base. So what this change of base is going to tell us is if you have any logarithm with some base, in this case a, we can rewrite it so that we can use a base 10 or base e. And the base 10 and the base e are both in our calculator. And so then we'll be able to use our calculator. So the way we're going to write it is we're going to have the log of x is going to go in the numerator. And then the log of the base is going to go in our denominator. Okay. So let's see what that looks like. So it says here, evaluate the logarithm using the change of base formula and then round your answers to 3 decimal places. So if we had a calculator, well, we're going to use a calculator here in a second, but first we can change this. So we're going to use log 11. And again, that comes from log and the number 11. And then log 3 is going to be from the log and the base 3. Okay. So when you enter this in your calculator, you need to be careful how we enter it. So we're going to type in log 11 divided by log 3, and then it's going to give you this number. We have to be careful since it's asking to round to 3 decimals. So my answer would be 2.183. Okay, let's look at B. So the same thing here. It looks, we have a pi as our base, but that's okay. So we take log of 0.5, that's going to be our numerator, and then log of our base is going to be our denominator. And then the answer, which we say it's approximate since we're rounding, if we enter it in the calculator, then we get negative 0.606. So we round to 3 decimals. This is a 5, so we round to 6. Okay, so the properties of logarithms that you'll be using, especially when you're trying to solve for a variable, are these right here. So we have log a of 1 is equal to 0. And the reason is if we change this to a logarithmic or exponential function, we would have a to the 0 power is equal to 1. Okay. And then here we have log a of a is equal to 1. And if you have the base is the same as your number here, then that's always going to be equal to 1. Okay, so we can set it up as a to the 1 is equal to a, so the exponent would be the same. And then the log of a of a number raised to a power of x, since they have the same basis, then that would be equal to x, and vice versa. If you have a of a log with the same base, then your answer was just going to be that x. And then the one-to-one property is actually one of the properties that you'll be using quite a bit, and it's actually, if that's your goal, then it's going to make it easier to do that. Okay, so you have log a of x is equal to log a of y. If the bases are the same, then we can say that x is equal to y, and so we can write it as x is equal to y. So let's try some of these. So it says use the properties of logarithms to write the logarithm in terms of log 5.2 and log 5.3. Okay, so in I think it's section 3.2, we were introduced with the properties, the product property, the quotient property, and the power property. So for the product property, what it says is if you have log of base a of 2 expressions, we can separate it as log a of the first expression plus log a of the second expression. In the quotient property, if we're dividing, then we can separate with subtraction. And then the power rule tells us that if you have an exponent, we can bring that to the front, and then we would have log a of u. All these properties work for the natural log as well. And for some of you, when you're entering your answers, this is an L and not an I, because that's one of the common mistakes. Students enter I instead of L. Okay, so here we can use the product property. So we can say that 6 we can write as log 5 of 2 times 3. Since they're being multiplied, then I can separate with addition log 5 of 2 plus log 5 of 3. Okay, so let's look at this one. So here we want to rewrite this, find the exact value without using a calculator. So the first thing is we see this cube root. Okay, so anytime you have a square root or a cube root or anything, these are just exponents. So for example, the square root of 2 is the same as 2 to the half power. The square root of the cube root of 2 is the same as 2 to the 1/3. And it doesn't matter what the index is, you're going to have an exponent of a fraction. Okay, so the first thing we want to do is rewrite that as an exponent. So this cube root, I can write it as 4 to the 1/3 power. And now notice that you have an exponent, or you can use the other property that tells you that if you have this same base as this one, then we know what the answer would be with that using the property. But let's apply the power rule here, which tells me to take the exponent to the front. So we get 1/3, a log 4 of 4. Well, log 4 of 4, we can use this property, right? Where we have the same base and the same number is equal to 1. So log 4 of 4 is just going to be a 1. And so 1/3 times 1 is going to be 1/3. Okay, any questions on this one? Okay. So here we're just getting practice with these logarithms, then we can use them to help us solve some equations. So find the exact value of the logarithmic expression. Sorry, I had to sneeze. So we have natural log of the square root of e cubed. So as you see a root, then it's better to write it as an exponent. So we're going to rewrite this fourth root as an exponent fraction. So we have e cubed to the 1/4. Then since we have an exponent, we can use the power rule. Or let's simplify first. So e cubed times 1/4. 3 times 1/4 is going to be 3/4. And now we can apply the power rule, which tells me to take the 3/4 to the front of natural log of e. So remember, for natural log, it's the same thing as log with the base e. So since you have e and e, then we can use this property again, number 2, which tells me that's going to be a 1. And so natural log of e is just 1, and we get 3/4 times 1 is 3/4. So let's look at the next one. So first, again, you see exponents, and if you can simplify within like e to the 4th, if you can simplify that, then we can apply the power rule to try to make it easier for us. So we're going to take the 4 to the front and the 8 to the front. So anytime you see natural log of e, some students like to say that they cancel. And so what they do is they just kind of scratch it out like this. But in reality, it becomes 1, right? Because it has the same base. So we get 4 times 1 and 8 times 1. So 4 plus 8 is going to be 12. Let's look at this one. It says use properties to expand the expression as a sum or difference. So notice here I started with 1 natural log, and our answer is going to be an expansion of that. So that means you're going to have multiple logs. Okay, so the first thing is we can take care of this 4. So the 4, I'm going to move to the front. Or we can use the product rule first. So let's, since they're being multiplied, z is multiplied times the parentheses. We can separate them with addition. And now we can apply the product rule. And I forgot my natural log in there. So let me just write it in there really quick. Or it might be in there in the next slide. Yeah, so I forgot the natural log in here. So now we have natural log of z, and then we can take the 4 to the front. So now we have natural log of z minus 1. And then there's nothing else that we could have done. And so now we started with 1, and now we multiple logarithms. I apologize about the plane. I'm actually sitting outside, so let's look at the next one. So we have 1 log, we want to separate it. So notice that these are being divided, so we can apply the quotient rule, which means that we can separate into division. So the numerator, and then minus the log of the denominator. We have a square root, so we can rewrite that as a fraction. So let's do that. So instead of the square root, we're going to write it as an exponent, as a fraction. And now we can apply the product rule, or the power rule. So I'm going to bring the half to the front. And then all this is still the same. And so we can factor x squared minus 9. That factors as x minus 3 and x minus 3. And now these are being multiplied, so we can separate those using the product rule. So I'm going to have 1/2 log of x minus 3 plus 1/2 log of x plus 3. So make sure that you don't forget that the half applies to the entire thing here. So if it helps, you can put those brackets there. So one common mistake is the half is only given to the first log, and then it's forgotten about the second one. So you have to distribute that to both logs. And then that would be our final answer. Let me go back. Okay, so again, if the half here is applied to both logarithms. So let's try a couple more. So we have log 8 of all of this stuff. So first, let's simplify using the quotient rule. Since they're being divided, I can use subtraction to separate my logarithms. So I'm going to have log 8x cubed minus log 8y cubed times e to the fourth. And now if we look at this, these are being multiplied. So we can separate them using the product rule. So for this right here, I'm going to have log 8y cubed plus log 8z to the fourth. Okay, so now let's take care of any exponents that we might see, or I guess we can distribute this negative. That way we can get rid of our parentheses. So negative times this would be negative log 8y cubed, and negative times this would be negative log 8z to the fourth. And now let's take care of these exponents. So we'll apply the power rule. So we're going to take the 3 to the front, this 3 to the front, and this 4 to the front. And so that would be our answer. So let's look at B. So I have this natural log of this 10th root. So first, let's rewrite the root as a exponent as a fraction. So that's going to be 1 to the 1/10 raised to the 1/10. And then notice that the x7th is being multiplied to x5th plus 7. So we can apply the let's apply the power rule so that we can get rid of that fraction of 1/10. So we can bring that to the front. And then we can apply the product rule so that we can separate this information. And since it's being multiplied, we can separate with addition. So natural log of x7 plus natural log of x to the fifth plus 7. Okay, so we can distribute 1/10. So 1/10 times each of these natural logs would give us 1/10 natural log of x to the 7th and 1/10 natural log of x to the 5th plus the 7. So all of these are done for a reason, right? And they're going to help us to solve equations, okay, which is going to be our ultimate goal. So here, if we apply the power rule, then we take the 7 to the front. So 7 times 1/10 is 7/10 natural log of x, and then 1/10 natural log of x to the 5th plus 7. Notice that the 5 here, I'm not going to take it, I'm not going to apply the power rule here because it's together with the plus 7. Okay, so now you have 2 logs. Now they want you to condense it to 1 log. Okay, so first we start by looking at these are being subtracted. So subtraction goes together with the quotient rule. But before we do that, we can also take care of any numbers that are in the front. So the numbers in the front are going to be, give me a quick second. The numbers in the front are going to be powers. So that means that like the 9 came from being exponent over here. So let's work this problem out. So the 9, we're going to go ahead and take care of the 9 first. And I'm going to write it again as an exponent. And then we can use the quotient rule to combine these. Since these are being subtracted, we can combine with division. So we're going to have log 6 of 3x divided by x to the 9th. And then from there, we can simplify this, right? So 3x divided by x to the 9th, one of these x's will cancel with one of the ones in the denominator. And so we left with 3 divided by x to the 8th. So again, when you're doing this, you want to first take care of any numbers that are in the front of the log. Okay, so if you look at this, you want to ask yourself, is there any numbers in front of this log? No, this one does have one and this one has one. So let's apply that first. So this would become log y to the power of 6 and log z to the power of 7. and then we're going to combine from left to right. And notice that these two are being subtracted. So we can combine those with division. So it's going to have x divided by y over 6, and then we have plus log z of 7. Now these are being added, so which property will I be multiplying or dividing? What do you guys think? So will I combine these with multiplication or with division whenever we have the adding? So Ruben says multiplication. Okay, so this would give us log x of y6 times z to the 7th. And we can simplify, right? So that's going to be x times z to the 7th divided by y6. Okay, let's look at the next one. So there's a lot of stuff going on here, but remember, first check, is there any numbers in here? No. Okay, the second one, here in this example, there was no parentheses. So we work from left to right. But here we have brackets. So you want to work inside of the brackets first. So we're going to combine this natural log of x plus 1 plus this natural log of x minus 1. And so they're being added, so we multiply them together. And now we can simplify inside. So you can multiply this out. So x times x is x squared minus x plus x 1. And we're left with x squared minus 1. And now we can apply the quotient rule. And since they're being subtracted, I can divide. Okay. So now this is what we're most interested in, is how do we solve for these type of problems. So here for the 2 to the x equals 4, my first goal is to ask myself, can this 4 be written so that it has the same base? Okay, and if it can, then I'm going to use the one-to-one property. Okay, so here we're going to rewrite 4 as 2 squared, right? So now since this is equal to this, or not, I mean, let me restate that. Since they have the same base of 2, then the one-to-one property tells me that I can set the exponents equal to each other. So my exponent of x is going to be equal to my exponent of 2. Okay, so on the next one, natural log of x minus natural log of 13. So one thing we can notice here is that the natural log, remember, is log of e, and this natural log is going to be log of e. So that means that they have the same base. Okay, so if they have the same base, then we're going to be able to use the one-to-one property. However, they have to be on the opposite sign of the equal sign. So the first thing I'm going to do is add natural log of 13 on both sides. And so I have natural log of x is equal to natural log of 13. Since this base is e and this base is e, the one-to-one property allows me to say that x is going to be equal to 13. Okay. Now the last one, whenever you see e to the x is equal to 13, the 13 we can never write as base e. So one of the, this process that we're about to do is something that you can use quite a bit to solve these type of problems. So to get rid of this e here and bring down the x, what we can do is multiply by natural log on both sides. So I'm going to have natural log of e to the x is equal to natural log of 13. The important thing is it has to be done on both sides. Okay. Now the natural log of e, remember that what I mentioned earlier, that natural log is the same as log base e, and then we have an e to the x. So since this base is the same as this one, then my answer is just x. Or sometimes people, they just say that natural log of e, natural log and the e cancel. But again, it doesn't cancel, it becomes a 1. So we get x is equal to natural log of 13. And then if you want the approximate answer, so in WebAssign, if they say to give an exact answer, then they're looking for the first answer. They want you to enter natural log of 13. If they say exact, if they want an approximation, then you can use the calculator, and then it'll tell you how many spaces to round off to. Okay, so I think, let me check. Let me just do this one last one, and then Mr. Carizales will finish the rest of the slides. So here it says solve the exponential algebraically. So since I have the same base, we can use the property, right? Which tells me that I'm going to take the exponents and set them equal to each other. So x is equal to x squared minus 6. And notice that it's quadratic because it has a power of 2. So in order to solve something to be quadratic, you want to move everything to the same side, set it equal to 0. At this point, you can factor or use the quadratic formula. So if you're going to factor, give yourself a minute or so. If you can't factor it, then it might not be factorable, so you can use the quadratic formula. In this example, it does factor as x minus 3 times x plus 2. We can set each factor equal to 0 and solve for x. So x is equal to 3 and x is equal to negative 2. Any questions on these right here? Okay, so Mr. Carizales will finish the next slides.
Thank you, Ms. Chuka. Awesome. All right, so let's continue solving for x, and we're going to be applying our properties. So let's go ahead and start with this first one. We have 5 times 3 to the x is equal to 20. So since we want to solve for x on this particular problem, we want to try to isolate it as much as possible. So there's a 5 being multiplied to this. So the first thing that we would want to do is go ahead and move the 5 to the other side. So since 5 is being multiplied, opposite to that is dividing or division. So we're going to divide both sides by 5. So we have 3x is equal to 4. Now what we can do is we can apply our properties. So since we want to use our properties in order to solve for x and bring this down, as Ms. Chuka had mentioned, we can use our power properties. We're going to take the natural log of both sides. Again, whatever we do on one side, we got to make sure we do it on both sides. So this will give us the natural log of 3 to the x is equal to natural log of 4. Okay. Again, our power property will allow us to bring down the x. So we're going to have x times the natural log of 3 is equal to the natural log of 4. Again, so the last step for us to solve for x is just divide both sides by natural log of 3. And is going to give us x is equal to the natural log of 4 to the natural log of 3. And again, it's very, very important, as Ms. Chuka said, when dealing with these problems on your homework on WebAssign, if they never say to round, that means that they want an exact answer. And this is the exact answer. They want the natural log of 4 divided by the natural log of 3. If you ever come up with a problem that says, give your answer to 2 decimal places, what that means is they want you to give an estimation. They want you to use your calculator and round. Okay. All right. So if they asked us to do an estimation, again, we would plug it into our calculator. Don't forget your parentheses. The natural log of 4 divided by the natural log of 3 is going to give us 1.26185. Again, on our particular answer, we rounded to 3 decimal places. All right. So let's go ahead and work with B. Again, we want to solve for this x value here, but we have a subtracting 9 to this. So let's go ahead and isolate our x as much as possible. So what we'll do is we're going to add 9 on both sides. And this is going to give us e to the x is equal to the 27. Again, because I want to use my properties to bring down the x, I'm going to take the natural log of both sides. Right, so this is going to give me the natural log of e to the x is equal to the natural log of 27. Again, we're using our inverse property, or you can use your power property where x is being multiplied times the natural log of e. And we know now that the natural log of e is equal to 1. So this is going to give us x is equal to the natural log of 27. Again, this is our exact answer. If we want an estimation, We plug it into our calculator. Natural log 45 will give us 3.807. Again, we rounded to 3 decimal places. Okay. All right. Let's go ahead and solve for this one. Okay. Let me give you all a little bit of time to write it out, see what the steps would be. Okay. Give you a second. All right. So let's go ahead and get started. And as I mentioned, on this one, they actually want us to answer both ways, right? They say solve the equation algebraically, and then it says approximate the result to 3 decimal places. So let's go ahead and get started. So we want the natural log of x is equal to natural log of 4. So if we want to get rid of our natural log again, we can use our inverse property. And what we can do is we have here, or we can convert it. We can convert our natural log into a logarithmic property. Here is the same thing. The log of e to the x is equal to the natural log of 4. And I can convert this now, since it's a log, it's better to see. I can convert it into an exponential. And my base of my log becomes the base of my exponent. The answer of my log becomes the exponent for my base, and the input of my log becomes the answer of the exponent. So here we have e to the negative 4 is equal to x, and when I plug that into my calculator, it has 0.0183. Again, because they want us to round to 3 decimal places, I look at the 4th placement value. It's a 3, so it's less than 5, so my answer is just 0.018. Okay. All right. Any questions before I move on? Okay, please ask if I go too fast or there's more clarifications. All right, let's solve these two. Okay, so we have a 2.8 is equal to the natural log of 3x. Okay, all right. So what we want to do is we want to change to an exponential form so we can better see it. And this step you don't have to do, but it's good just for practice purposes, converting from exponent to logs, because you do have several homeworks that will ask you to do that. Okay. All right. So let's go ahead and convert this natural log of 3x into an exponential form. So the first thing we'll want to do is, just so we can better see it, convert it into a log format. So this is log of base e to the 3 to the x, okay, is equal to 2 to the 8x. So again, converting to our logs, so we have e to the 2 to the 0.8 is equal to 3x. Okay. All right, so then we're gonna isolate the x, so we're gonna divide by 3 on both sides. Okay. Then again, if they want the exact answer, this is precisely how you would leave the answer on the computer. But if they want us to estimate, we again plug it into our calculator. We go e to the power 2.8, close parentheses, divided by 3, and this is going to give us 5.48154. Again, they want us to round to 3 decimal places, so my answer is going to be just 5.482. Okay. All right, let's do B. This one's a little bit more complicated. Again, we want to solve for the x here, so we want to isolate it as much as possible. So the first thing we want to do is we're going to move this 5 to the other side by subtracting 5 on both sides. Okay, so this is going to give us negative 5 natural log of x is equal to 11 minus 5, which is 6. Okay, so now the next thing we want to do is we want to get rid of this negative 5. So we're going to divide by negative 5 on both sides. So this is going to give me the natural log of x is equal to 6 divided by negative 5. All right, and if we wanted to solve for the x, we can change it to an exponential form again. Okay, so the log of base e to the x is equal to 6 to the negative 5. Again, my base is e on the log, so it's going to be the base of my exponent. The answer of my log becomes the exponent of my base is equal to x. Okay, so I can plug that into my calculator. Again, we want to encapsulate the negative inside the parentheses, so make sure we get the right answer. and we get x is equal to 0.301. Okay, so our properties are going to come in very, very handy to solving these exponential problems. Okay. All right, so let's do a couple more. Let's practice, practice, practice. All right, let's start with A. Here, we have the natural log of x minus the natural log of x plus 6 is equal to 7. Oh, what I can do is I can use my properties to condense this log. Since I have multiple logs on this left-hand side, let's condense it so we can use our other properties to isolate the x. So since these two logs are being subtracted, I can use my quotient property. My quotient property says that I can divide these two logs into a single log, right? So then I have the natural log of x divided by x plus 6. Again, we read this from left to right. So the first one always goes on top, and the second one always goes on the bottom, our denominator, okay? So we have natural log of x divided by x plus 6 is equal to 7. Okay, and then we can apply what we have been doing before. We can change it to an exponential form, okay, for practice purposes. We have log of e to the x over x plus 6 equal to 7. Let's go ahead and convert it to the exponential form. So again, our base is e, our output is 7, so it's going to be our exponent. Then we're going to solve for this. Okay, so what we have is to solve for this, we're going to multiply the x plus 6 on both sides. Okay, so we have e to the 7 times x plus 6 is equal to x. Right? Now we're going to distribute the e to the 7. Now the reason why we're doing this is because, again, we have the x on the numerator and on the denominator, and we want to make sure to isolate the x. So you'll see what happens when we distribute. So when we distribute this e to the 7, okay, we're going to have e to the 7x plus e to the 7 to the 6 is equal to x. So now what I can do is I can move it to the right side, this portion that has the x. So I'm going to subtract e to the 7x on both sides. Okay. So when I do this, now I'm able to factor out the x. So I can isolate it to one single x. Okay. So when I do this, I can factor out an x. So e to the 7x to the x, I can factor that one out, just leaving me with e to the 7 minus x. If I factor that out, it leaves me just with the 1. Okay. Now, if I want to isolate the x, the last thing I want to do is divide both sides by e to the 7 minus 1. Okay. All right. So when I do this, I have x is equal to negative e to the 7 times 6 over e to the 7 minus 1. Okay, and if I plug that into my calculator, I get negative 6.005. Okay, and this particular one problem, I started using my quotient property. Now let's look at this part B. Okay. Before I move on, again, when we're dealing with negatives, you always want to check your solutions, right? You want to make sure that they make sense, that you can apply it. Now, so since when we're doing natural logs, our natural logs can have a negative value. So on our particular one, our problem right here, when we plug in natural log of a negative number, we gotta, exactly, Ms. Chuka, we want to be careful on our domain. We want to make sure that the input that we're plugging in is acceptable, that we're going to get a real number. Okay, so we can't have negatives inside the natural log. This particular one problem will give us a no solution. Okay, all right, so let's go ahead and do B. Okay, on B, we have the natural log of x plus 9 is equal to the natural log of x minus 6 minus the natural log of x plus 6. Okay, on this particular one, now on the right side, again, we have two logs that are being subtracted. We want to combine those, right? So what we can do is we can use our quotient property again, and this is going to tell us that we have the natural log of x minus 6 divided by x plus 6. Now what we can do now is we can use our one-to-one property, we see that we have two logs on both sides of the equation. We have the natural log of x plus 9 is equal to the natural log of x minus 6 divided by x plus 6. For these two logs to be the same, this means that the inputs have to be the same. So what I can do is apply my one-to-one property, and it says x plus 9 must be equal to x minus 6 over x plus 6. So again, we're going to solve pretty much the same way that we did the one before. We're going to multiply x plus 6 on both sides to try to combine the x's together. Okay, so when I do this, we have x plus 9 times x plus 6 is equal to x minus 6. On this particular one, we're going to do FOIL. We're going to multiply the x times the x times the 6, and the 9 times the x, and the 9 times the 6. Okay, so when we do this, we have x squared plus 6x plus 9x plus 54 equals to x minus 6. Let's go ahead and combine our like terms. So we have x squared plus 15x plus 54. Okay, and let's go ahead and move everything to one side so we can, if we see, we're going to end up with a quadratic equation, and we know that because of the highest exponent is a 2. Okay, so when I move the x to the other side, I'm going to subtract an x on both sides, the negative 6. To move it to the other side, I'm going to add a 6 to the other side. So when I combine my like terms, I'm going to end up with the x squared plus 14x plus 60 is equal to 0. And again, you want to take a couple of minutes to see, hey, can I factor this? And if you can't, again, the powerful tool you have at your disposal is using your quadratic equation to solve for these x values, right? So on this one, just for practice purposes, we decided to use the quadratic equation. Okay, here my a value is 1. Okay, so it's right here. My b value is 14. Okay, and my c value is 60. Okay, so when I apply my quadratic equation to it, I see that I end up with a square root with a negative number inside again. And just as before, we want to be careful as far as our domain. Just like with the fractions and quadratics, we don't never want a negative number in here. So the answer for this particular problem is going to be a no solution. Okay. Now you're thinking, we did all this work to get a no solution, but later on, this is good practice because later on we will show you how to solve these that have no solutions. Okay, so this is good practice to solve these types of problems, because these problems later on we will see much further. Okay, all right. So let's go ahead and work this one. Okay, I'll give you a couple of seconds again for you all to start. We gave you a little hint. Again, we're going to apply the quotient property again. Okay, I said minutes. Let's try seconds, because then we run out of time. All right, let's go ahead and work it together. So again, we must like the quotient property. So we have log here, log of base 9 of x minus the log of base 9 of x minus 8 is equal to 1/2. Now, also want to mention, for us to apply these properties, we have to be dealing with the same logs. So if these two logs had different bases, we could not use our properties. So be very careful when you're doing your homework that before you start applying the properties, that the bases on all the logs are the same. Because if they're not, then you can't combine them together. You can't do anything with them. So since these two have the same base, I can apply my quotient property. Quotient property says that I can divide these two to a single log. So I have the log of base 9 of x divided by x minus 8 is equal to 1/2. Okay. All right. Now let's go ahead and notice that we have an exponent. Okay. So of a square root. So we can take the 9 to this, or convert it to an exponential form, which is going to give us 9 to the 1/2 is equal to x over x minus 8. Okay. All right, so here we have the square root of 9 is plus or minus 3 is equal to x minus x divided by x minus 8. Again, we want to combine our x's, so we're going to multiply by x minus 8 on both sides. Okay, when we do this, we're going to do it twice. We have a plus 3 and we have a negative 3. Okay, so let's do the plus first. So we have 3 times x minus 8 is equal to x. Distribute our 3. 3 times x is 3x. 3 times a negative 8 is a negative 24. Okay, let's move the x to the left and our number to the right. So subtract x on both sides, we have 2x. Add 24 on both sides, we have equals 24. Divide by 2, so x is equal to 12. So when we had a positive 3, our x is equal to 12. Now let's do the negative 3. Okay, we're going to distribute again our negative 3. We have negative 3x. A negative with a negative is a positive, so we have a positive 24 is equal to x. Again, let's subtract our x and subtract our 24. So it's going to give us minus 4x equals negative 24. Divide both sides by a negative 4. So x is equal to 6. So the value that we got when our left side was a negative 3, our x is equal to 6. Okay. Any questions? All right. So we want to always check our solution. Okay. So let's check. Since we have two answers, let's make sure that we can satisfy our condition. So let's go ahead and plug in our 12. Okay, so we have log base 9 of 12 minus log base 9 of 12 minus 8. Okay, so here all of our numbers are positive, so then x is a solution. But look what happens when I plug in x equals to 6. I can have the log of base 9 equals to 6. This is valid. There's no problem with here. But when I plug it in here to this subtraction, x minus 8 or 6 minus 8, again, we come across a log with our input of a negative number, which we cannot have this. So this means that x equals to 6 is not a solution. So my only solution for this problem is going to be x equals 12. Okay? So always check your solution, especially when you have two of them, making sure that either both or one of them is the true solution. Okay. All right. So, oops, I think if we finished a little bit sooner than we have. Let's go back to this one. Does anybody have any questions on these properties?
Any
All right.
questions in general?
In general, yes. Go ahead, Rocio.
On the web assign, will it ask us to check them to input the right one or
Yes. So for instance, it's like on this particular problem, like if you had this problem on WebAssign and in your answers you put 12 and 6, the computer would mark it wrong for you because again, by you checking, you discovered that x equals 6 cannot be an answer. It gives us it does not exist solution. So it's imperative that you always check, even though the computer is not going to tell you to check, but you need to check because you can discover something like this, that your answer, even though you got a number, the answer could give your problem an error. So because again, it's thinking like in your calculator. If you put in your calculator the log of -2, your calculator is going to say error or does not exist. So it's always good to check. It's not going to tell you, but it's very important that you check your answer.
Okay, thank you.
Oh, my pleasure. Any other questions? I don't know. Let's see. see if we can go back here. Since we have a little time, let's practice. Let's do this. What if we since we practice a lot with the quotient, what would happen again? I don't know if we're making it a hard problem, but what if this was a plus over here? Okay, how would this problem change? Okay, so let's go ahead and work it out. So now we're not going to apply our quotient property, but now what we're going to apply is our product property. Okay, so we have here two logs that we're adding them together. So what we want to do is apply the product property, and the product property says that I can multiply both of these logs. So I have the log of base 9 of x times, and let me use double parentheses, times x minus 8, close my second parentheses, equals to 1/2. Okay, all right. So what I'm going to do is I'm going to go ahead and distribute my x to the x minus 8. This is going to give me the log of base 9. Okay, x times x is x squared. X times a minus 8 is a minus 8x equals to 1/2. Okay, and like since I'm doing this on paper, what I like to do is I always like to apply my inverse property. So here I have a log of base 9. Instead of rewriting it, what I like to do is use my inverse property and say this, add this into an exponent, just so you can see how a different way of applying the properties. I can do a exponent that has a base 9, okay, and I'm going to take it to the log of base 9 of x squared minus 8x. But again, whatever I do on one side, I have to do to the other side. So I have a base 9 on this side to the 1/2. Okay, all right. So because it's my inverse property, what this means, again, not that they cancel, but this log of base 9 to a base 9 becomes 1. Okay, so this side becomes just x squared minus 8x. And then again, this one, we know that the 1/2 can be rewritten as the square root of 9. And we know that the square root of 9 would be plus or minus 3. Okay, so just like before, we're going to have two answers. So just so we can have different colors here. So one of the answers is going to be, or to solve the quadratic, is going to be x squared minus 8x. Again, if it's a plus 3, to move it to the other side, it's minus 3 equals 0. That would be one of our problems. The other problem would be x squared minus 8x plus 3 equals to 0. Okay, again, so here we would want to try to see if we can factor it out. I cannot factor this out, so I would use my quadratic equation. Again, here my a value is 1, my b value is -8, my c value is -3 on this particular one, and on this one everything would be the same except for the c. The c would be now a +3. Okay, so just to practice again, plugging it in. Let me see if I can erase this. So let's do this one. The x squared minus 8x minus 3 equals to 0. Again, we're practicing our quadratic. Okay, so we have x is equal to minus b b, which is a -8, plus or minus the square root of b squared, which is -8 squared, minus 4a, in our case is 1, c is -3, divided by 2a, which is 2 times 1. Okay, so we have x is equal to a negative times a negative is a positive, so we have 8 plus or minus the square root. Okay, -8 squared is 64, positive 64. Minus, okay, 4 times 1 is 4, and 4 times a -3 is a -12. All over 2. 2 times 1 is 2. Okay, all right, so let's simplify our radical. So we have 8 plus or minus the square root of a negative. A negative is a positive, so 64 plus 12 is 72 over 2. Okay, now one of the things that we want to do, because again, WebAssign always asks you to give exact answers and leave things with radicals. Let's go ahead and simplify this square root of 72 using a factor tree. Okay, and what I like to do is, since this is the square root, means that I want to find pairs of numbers. So since it's an even number, I'm going to divide by 2 this number. So here, 2 will go into 7 3 times, with a remainder 1, and 2 will go into 12 6 times, right? So then I have 36. So I still have a composite number. I'm going to divide by 2. 2 will go into 3 1 time, remainder 1. 2 will go into 16 8 times. Okay, let's do it again. 2 will go into 18 9 times, and then 9 be written as 3 divided by 3. So if I have all my building blocks of 72, okay, if I write them down, I have 2 times 2 times 2 times 3 times 3. Okay, so you see it's all about making pairs of numbers. So I have a pair of 2's that can come out of the radical, and then I have a pair of 3's that can come out of the radical, leaving me with just a lonely 2 inside. So the square root of 72 can be simplified to 6 square roots of 2. So someone just double check my math, and I think I did a subtraction or addition wrong. So this should be, I'm told, 76. Okay, did I write it wrong, or I did the math wrong? Okay, so again, I can continue simplifying if it was 76, but just because we were just practicing on this when we're making it up, and because we only have 2 more minutes, okay. Again, if we were if we're giving the exact answer on this one, we would leave 8 plus or minus, what are we 6 square roots of 2 over 2, okay, but we want to simplify this even further, so this could simplify to 4 plus or minus 3 square roots of 2. Okay, again, this number, again, even though it might not be the 72 if it was 76, and it's just a way that to practice our properties, to show that I can use properties to solve for x. And again, any questions? We got a minute left. Want to make sure to use all the time as possible to help you all out. Any questions? So thank you, Peter, for bringing that number correct. Okay, guys, so for those who end up seeing this video, okay, make sure you answer the question below. Answer the value for x for A, and you can answer the x for the B. Okay, this is so you can get credit with your teacher for extra credit. Okay, don't forget to fill out your survey. Go to the link listed above. Right. Any other comments, Ms. Chuka, before we leave?
No, that was it. Have a great 4th of July weekend and everybody enjoy your holiday.
Yes, enjoy your holiday. Stay safe. Bye.
Alrighty, well, we want to take this moment to thank Mr. Ruben Carrizales and Ms. Yvette Chuca for presenting today. Also, thank you for the audience for becoming a wonderful audience, and we hope to see you next week. Next week, we're gonna on the Math 1314 room. We're gonna be talking about exponential and logarithmic form functions, and on the Math 1324 room, we're gonna be talking about graphing equations and navigating through MATLAB course and writing equations. We'll be doing that Friday, July 9th, which is next Friday. Also, just for the audience to know, we have tutors available. If any of you have any questions about today's presentation or any questions in general, please feel free to send by and let us know. Like I said, we have a tutor available for you guys. Other than that, let me go ahead and stop the recording. You have a good rest of